Okay, so well, a couple of kind of bookkeeping things. So just as a reminder, I'm skipping town at 2:30 p.m. tomorrow. So I'm gone during final exam week. I typically wouldn't do that, but it's a free cruise. My brother scheduled his cruise 2 years ago for his kids, so it's like a big family reunion thingy. So I'm out of here. So your exam is going to be online. It'll be the same exam that I would do otherwise, but it'll be online. I'll put a little extra time on it just in case there's any complications or something, because once you start it, you're on the clock. I just need you to take that exam by, let's say, midnight on December 17th. So I'll put the due date on it. So you can decide when it best fits your schedule with your other final exam schedule. So hopefully that benefits you and makes up for me not being here and that kind of stuff. But once you sit down, I'll probably put a 3-hour time limit on it. Just so you can. I guess I won't officially say you can't use your notes and stuff like that because you're going to do it anyway. So if you like to use your notes, that's okay. I don't know how much it'll help you and that kind of stuff, but obviously I'm not sitting there in 3 hours, so whatever. But it'll be the normal exam like I would give in class. There'll probably be 10 questions. 3 or 4 will be programming. The rest of them will be short answer. Things like what is abstract? What is this and super? What do they mean? That kind of stuff.
You're gonna go over it today?
Yeah, I'll kind of go through the slide set. We'll talk about the things that are important. In fact, let's do that first so we make sure we cover that. We don't run out of time. But expect the exam to be pretty similar to the first exam, but so it will be cumulative. So there's a possibility I'll ask questions again. I can almost guarantee you I'll have that question about how do you call instance methods versus class methods. Too many of you missed that on the first exam, and it's so important, and we've said it so many times. So we'll say it again today. Write it down, memorize it, bring it into your soul. Okay, it's just a really important concept that's going to benefit you so much, being able to just instantly identify those things. Because reading documentation is so important, because we're not going to memorize these languages, right? I think I've referenced in here, I've been programming in Java since it came out. And I've probably seen 10 or 15% of the whole language. There's just so many things in the library that you never need, right? So it's beneficial that when you have a problem, some weird problem that plops into your lap, and you need to go and solve it, that you're able to go and kind of look at some documentation with something you've never used before and be able to immediately start using it because you understand how to read the documentation. Does that make some sense? So pretty important concept. So so how long has that been? That's 1996. It's 20. I've been programming in Java for 20 years. And I've seen 10 or 15% of the language. It might be higher than that, but whatever. Not the whole language in 20 years. That's a lot of Java experience, right? You're going to run into that with every single language you're ever going to deal with. You're not going to see the whole thing. You're going to see what you see based on what problems you had to solve. Super important skill set. So I promise that question will make the exam. I will be writing the exams tonight, tomorrow, and on the beach on Saturday.
You should incorporate that into it. Like have one question, be like, so I'm sitting on a beach and I need to solve this problem.
Yeah. What are the I need to calculate the chances of a shark attack. I'm a pretty large mammal. Are they going to think I'm a sea lion? Is that a real possibility? Or
do that for the conversion ones. I'm on the beach and I see a bunch of ones and zeros.
Yeah, there'll definitely be a conversion problem. Love conversion problems. So if there isn't a conversion problem, that means I switched up my meds again. Yeah, definitely like those. Definitely expect here. I'm going to give myself a cheat sheet, so then you'll know those questions will make the exam. And also remember, for those of you who went to the hackathon, you have some extra credit coming. So what I'll do is, and also a reminder for the rest of you, if you do better on the final exam than you did on the midterm, I'll replace your midterm and with that final exam score. And what I'll do is I'll apply that 10% extra credit in the way that will benefit you the most. So I'll do that after I've replaced stuff. So a 90 will turn into a 100 twice, which is good, right? That should encourage everybody in the future to show up to the hackathon. Those are good extra credit opportunities. But typically, that's, from my perspective, it's pretty low risk. The exams in my class average is usually, let's say, a 70, 75, something like that, but very few people get a 70 or a 75. Typically, you've shown competence, and I typically don't take off a whole lot of points for competence. If you saw the first exam, if you pretty much got the question right and just made some stupid mistake, 70% of the time I just circle it. Sometimes I put an LOL or something like that. I don't even take points off. Otherwise, I'll barely hit you for some points. If you show complete insanity on there, I mean, I'm not even going to waste my time grading it. So I just put a 0 and I move on with life. So you typically get a lot of 30s and 40s on the exam, and then you get a lot of 80s and 90s on the exam. So be in that 80s, 90s group. Show me that you're competent. You'll get a decent grade. It'll replace your midterm if you sucked on the midterm, and you'll get your A or B in the class, and I'll see everybody in 300. That would be my preference, right? Nobody likes failing people. Why? I like failing people a little bit, but I like failing people who deserve to fail. I don't like just going out of my way to fail people. The one time, I have to say I did get enjoyment out of it. This is when I was teaching at Western Illinois University. It must have been like 14, 15 years ago. I had a student, and he was like probably the best student in class, really sharp. And back then, when you filled out the grades, it was like a Scantron thing. I got off a bubble. I failed this kid. He probably had 104% of the class. He comes to my office just flipping out. I got some enjoyment out of that because that kid probably lost 2 nights of sleep or something over it. But I had to go back and fix all the other grades. But grades that were like close, let's say I gave somebody accidentally a B- and they deserved a C or C+, I just left it. I mean, because how would that make you feel if you got a grade and then it gets switched to a crappier grade? I mean, if it was like, if I gave somebody an A and they deserved a D, I switched it. But so even though I've never made a mistake in my life, that one was close. All right, so 250 exam, conversion question, static versus non-static. That's going to be there. All right. Now, let me kind of work since the midterm. That was a review of the global scope. All right, so that's early on. All right, so new keyword. We had arrays in the midterm, right? Okay, I think that was kind of where we started. This might not have been on the midterm. No, we had methods on the midterm. So really, it's objects that we've done since the midterm, right? Okay, let's kind of start with this. All right, so definitely understand the concept of an object type versus a primitive type. Primitive types can only hold a value. Object types can hold a value and potentially do more. So we've kind of been working with some object types. Specifically, we've had a player object that we've been manipulating. So we upgraded a previous assignment to use objects. So a player object keeps track of the stuff related to players. It keeps track of jersey number. It keeps track of kind of relative skill set. I think we maybe put a couple of other things in there more recently because we've been looking at the whole inheritance model and stuff like that. But understand that power that objects bring to the table, and also the concept of object-oriented programming, how kind of the goal of object-oriented programming is to allow us to solve problems in a similar fashion to how we solve problems in real life. I doubt I would ask like a direct question like, what is an object? It's kind of arbitrary how to answer that, right? You just kind of slap some crap on the paper and you hope that you said the right keywords or something like that. So I probably wouldn't ask a question like that. But understand that concept, because the exam will likely really revolve around the whole concept of object-oriented programming. So even when I review a concept from the first half of the semester, I'll probably do it within the context of an object-oriented thing. I might show you some code that's an object, and I might say, you know, here is a, in fact, this would be a good question now that it popped into my head. I might show you an object, show an object with constructor, and have you call the constructor. So / create an instance of the object. And as I'm kind of thinking about this, what I might do is I might kind of give you an object kind of at the top and then have 3 or 4 questions that ask you to use that code. This gets back to the whole idea of being able to read documentation. So I might give you something, it probably wouldn't be the player object, but I might give you something like the player object that keeps track of 3 or 4 fields, has a constructor that takes something in as a parameter, and then maybe has 2 or 3 methods. Maybe there's a getter and then maybe another method that does something other than that. You know, that, and then I might ask you, create an instance of that guy. Use that instance to call some method or something like that, you know, or solve some problem using that instance, that kind of thing. So that could fall into that category of one of the programming questions. I might ask you to write a method that would augment that object. So, you know, add a method to that object, but just show me the method down here that would allow you to do X, Y, and Z or something like that, where you're manipulating fields, showing me that you understand how to use the this keyword, that kind of stuff. Make sense? Okay, so I kind of see that on the exam, me maybe giving you that definition of an object and have you show me you know how to use it. But really drill you in that idea of when you see a constructor, be able to create an instance of that object, calling that constructor the correct way. All right. Okay. Maybe something along these lines. I don't know how it would fit in the exam in terms of a question, but you know, something about showing your understanding of arrays versus strings. You know, before the midterm, we talked about it. Well, we talked about arrays and strings, but we started focusing on the real differences. So we were using them with collections of things and stuff like that in the second half, especially when we started storing arrays of objects. All right, so arrays are effectively read and write, correct? So we can change an element at a specific bucket in an array, where we cannot do that with a string. We have to build a brand new string. Okay? Arrays are also fixed size to begin with, and if we want to create a larger array, we need to adjust the array. Strings, we can concatenate onto the string to add stuff to it, and we can manipulate the string in all sorts of ways. So strings are a pretty important core concept in Java. I would be surprised if you didn't have to use a string to some extent on one of the programming questions. Manipulate the string, do something with strings. Also understand the concept of arrays of objects, which really aren't any different than arrays of ints or arrays of chars, other than the fact that the value at the bucket is a memory address which points to an instance of an object, and that object has all those extra features where you have methods and you might have private variables, that kind of stuff. Definitely understand the difference between public, private, protected. I probably, just as I'm kind of going through it, would not ask a question unless I needed a filler question that was non-programming. Kind of like tell me the difference between public, private, and protected. Instead, it would probably come in the form of that code that I give you. I might have the fields be private, and then when you're writing your solution to that, you'd have to show me that you understand that you have to use the getters or the setters to manipulate those guys rather than directly accessing those fields because they're private. Make sense? Similarly, if I give you an inheritance model, so maybe I have a human object and a player object where player extends human, I might have them be protected, so you should understand how that pass-through effect kind of works. Okay? So some of the, let's say, non-programming questions are going to involve you maybe telling me how a certain part of the program works, or maybe even writing one line of code. I would say one line of code would not qualify as a programming question. Programming questions are going to be like write a method that does something like that. Okay. I think everybody pretty much got that right on the first one. I think out of desperation I could, if I needed the question, but I doubt I will need the question. I typically try to make the exams 10 questions, so if I, need a filler or something like that, or sometimes I've put Hello World kind of early in an exam as like a warm-up to get your brain firing. But I think everybody got it right on the first exam, so I probably won't put it on there, would be my guess. I would still make sure you know how to do it, just in case, but hopefully it's ingrained at this point. Okay. Polymorphism is always a question I like. So that idea of having more than one method that has the same name but a different number and or type of parameters. So here's some examples. So we can have 3 methods named my method. One of those takes 2 integers, another one takes 1 integer, and another one takes a single char. And Java will automatically figure out which one you meant based on the parameters you send it. If you pass it 2 integers, it'll call the version of that method that takes 2 integers. Now, do understand or do remember that if I threw another method in here, these 2 methods are the same method. That would not fly in Java. This would be an error. Even though I've named the variables different variable names, it's 2 ints. That's what Java cares about. It doesn't care about what the names of your variables are. That just dictates inside the body of the method how you refer to those variables. All right. To Java, this is a method named my method that takes 2 ints. This is a method named my method that takes 2 ints. Those conflict with each other. Okay. Now, with that in mind, polymorphism is different than method overloading. Method overloading would come in the form of inheritance. So if I had a human object that had a my method that took 2 ints, and then I inherited from the human object a player object, I could choose in that player object to rewrite my method, have it take 2 ints, and have it do something different. Okay? That would not be an example of polymorphism because it's in different classes, and that would be allowed. I could have in fact, in that case, you would want to have a method with the same name. You could have the variable names be different, but they both need to be ints. Because what Java does, and this kind of extends from an earlier concept, that all variables resolve to their most local definition. Something we've said a lot of times, right? All variables resolve to their most local definition. Methods are the same thing. Okay, and that comes into play with inheritance. So if I call the my method that takes 2 integers on a player object, it will first look in player object for that method. If it doesn't find it, then it'll bounce up to the human object that the player object upon which the player object was built. And and look for that method. Okay, so it'll resolve to the most local one it finds, the first version of that it finds. Does that make sense? So it's the same concept as resolving a variable across multiple scopes, except this is kind of walking the inheritance hierarchy, looking for that method. All right. All right, but I do like polymorphism as a question. Historically, I have asked you to just define polymorphism. That's been a popular question. So unless I need a programming question where I ask you to show an example of polymorphism in code, where I effectively ask you to, inside of a class, write two methods with the same name but a different number or type of parameter. It's kind of me asking the same question. Instead of you defining it in words, you're defining it by writing two stupid little methods, right? They can do whatever you want them to do, but they would have the same name. So you could write a method called myMethod that takes 2 ints, another method called myMethod that takes 1 int. That's an example of polymorphism, regardless of what the methods actually do. Make sense? All right. Yeah, so here's that method overloading thing. So this is that inheritance thing that we just talked about. So understand the difference between those. Okay. Any questions about the difference between those? Pretty important concept, but hopefully it's related enough to some earlier things that it's not like a complete change in philosophy or anything like that. Okay. Definitely understand this versus super. In fact, I'm going to put that on the list here. Okay, so understand that concept that this is how a variable refers to itself within itself. Okay, so if I'm dealing with a specific instance of player, inside the implementation of player, that instance refers to his fields and his methods using this dot. Okay, that means if I'm that player instance, it's my version of this field, my version of this method. That make sense? Okay, super refers to my parent. Okay, if I'm a player object that I was and I inherited from human, that means that a variable was created called super because an actual instance of human was generated. Okay? And that instance of human, in fact, that's probably the one situation where an abstract class could be instantiated because it's magically instantiated by Java, and Java can do whatever it wants. All right? I'm not exactly sure how it's probably not a full-fledged normal plain Jane instance. It's some kind of specialty thing that Java knows how to do that gives you access to that previous your parent class. But in any case, super is the instance of your parent. All right. So if I'm a player, so I'm a player. Super would be my direct parent. So super would probably refer to my dad, let's say, something like that, or my mom, okay, as opposed to one of your parents. Make sense? Okay. So this versus super, kind of an important concept in the whole inheritance model and the object-oriented programming model. You won't always have a super. Well, actually, that's not true. You will always have a super. By default, what will super point to? If you don't do any specialty inheritance, what will the variable super reference? Go ahead.
Object class.
Yeah, the instance of the object class. All objects innately inherit from the object class, unless you specify that they inherit from something else, and that guy would inherit from the object class. So indirectly, a player would inherit from the object class, even though they directly inherit from human. So player inherits from human, which inherits from object class, which means a player is a object. It also is a human. Make sense? All right. Constructors, be able to write a constructor. For example, if I gave you that code that already had a constructor in it, that that I wanted you to call, show me you understand how to call the constructors, I might ask you to write a second constructor, okay, which would maybe be an example of polymorphism, right? It would be a method, even though constructors are a little bit different than methods. How are they different than methods? How is a constructor different than methods? Different than a method. If I showed you the definition of a constructor versus the definition of a method, how would you tell those guys apart? Go ahead. Okay, that's correct answer A. Okay, all constructors have, well, constructors do not have a return type. Do you know why? Okay, why don't constructors have a return type? Not him. I think everybody's pretty aware he kind of knows his stuff. He would be a good person to cheat off of for homework. Say this again. Not called to the main. Tell me more about what you mean. It sounds made up. How are constructors always called? What keyword will we always see? The new keyword. And what does the new keyword do? Yeah, gives us a memory address, right? Every single time the new keyword gives us a memory address. Well, it doesn't, but the thing is the constructor doesn't have a return type. And it doesn't have a return type because it's always used. Constructors are always used in conjunction with that new keyword, which always boils down to a memory address. So why should we waste our time writing a return type in there when the return type will always be a memory address? It'll be a pointer to that particular object in memory, right? So we don't have we won't have a return type because it's always going to be the same. That make sense? Okay. So now I'm going to ask the third complex question, and you're allowed to answer this one. This is a harder question. I haven't asked the question yet, but you're allowed to answer this one. Okay. So third question related to that is assuming we did have to, so this is kind of another reason why we don't have a return type. Assuming I said constructors do have return types, but the return type is always a memory address. Why is it that we don't have a return type? How would you write that return type in Java? When I say something is a memory address, what kind of variable holds a memory address? Go ahead. A who? Okay, at the end of the day, the value would be a hexadecimal memory address. That's true. Okay, but specifically, what kind of variable holds, historically, what kind of historic variable holds a memory address? Go ahead. A pointer. Okay, a pointer type holds a memory address. Okay, and what's the problem with pointers and Java? When I first taught this, I referenced Java textbooks and what I don't like about most of them. Go ahead.
Don't they say that we can't directly manipulate a pointer?
I wish they said something like that. I wish they, yeah. Typically, Java textbooks will say something like, pointers don't exist in Java. All right, because remember when we were talking about the history of languages, we kind of talked about that jump from C++ to Java. And one of the things that did for us is that kind of protected us from ourselves. It kept programmers from being able to make bad decisions because in C++, programmers are empowered to make bad decisions. So I think I probably used the example of the house, right? You're inviting me to your party. Here's the actual house. Open the door at 8. That would never make sense in real life, correct? Instead, you would hand me the address to where the house is, okay, and say show up to the house at time XYZ, right? All right, so C++ lets you choose to hand somebody the house. Java, it's not that pointers don't exist in Java. We've seen, he wouldn't have known that the type would look like a hexadecimal value if we hadn't seen them, right? We saw the crazy looking memory address thingies several times. Pointers exist. What doesn't exist in Java? What would be the more accurate thing of maybe put more simply than kind of what he said? In Java, we don't have a specific syntax for representing pointers. They've taken that away from us. Okay? In C and C++, we put a little asterisk. If we want to have a pointer to an integer, we would say int star. That's a pointer type. Okay? Instead of something being an int, we have a special syntax for creating a variable built for holding the memory address of a integer or of any other kind of type. Java removed that. Okay? We don't have a syntax that allows us to directly hold a pointer type. We have variables that hold pointer types. Any instance of an object, if we just tried to print that directly, would have a memory address in it. Okay? But we don't have a syntax for saying that. Okay? So if I said that a constructor had to have a return type, we would be at a loss in Java because we have nothing to put in there. We don't have the syntax. We don't have the language construct for saying it. Does that make sense? So that would be another reason why we can't have a return type in Java. But the real reason is why waste our time? It's inefficient. The return type is always a memory address, so let's not waste our time writing crap because it's always the same. Where when we have methods that we write that do have return types, remember this question was, how do you differentiate a constructor from a method? Okay? Methods that do have return types have unpredictable return types. We might have one method that returns an int. We might have another method that returns a string. Another method that returns a player. Every now and then we have methods that return nothing. When we have a method that returns nothing, what do we advertise as the return type? A method that returns nothing must have a return type. All methods do. But what would the return type be for a method that returns nothing? We should all know that one. Who? I just asked it 3 times. Did you take my my evening meds? I feel like I'm holding it together pretty well here, actually. Okay, so if we have a method that doesn't actually return a value, all methods must have a return type. We have to advertise to Java what our return type is. What would we put as the return type for a method that does not return a value? Void. Yep. Void is the return type for a method that doesn't actually return something. All right. These are all concepts that we should be able to work with for programming questions and stuff like that. Let's see. Anything else? Okay. So again, going back to the core question here, how do we tell the difference between a constructor and a method? Okay. So she's absolutely right. One way is if you don't see a return type, either an error or it's a constructor, right? How else can we tell the difference besides the return type thing? That's when you're calling a constructor. You'll always see the new keyword. So I'm talking about on the definition side. If I'm looking at the actual class definition, I see a constructor written here, and I see some methods written down here. How do I know that this guy's a constructor and these guys are methods? Well, she already said methods don't, she already said that constructors have no return type. So methods will all have some kind of return type. It might be void, it might be int, it might be something. No, he just said that. That's wrong. We already said that's wrong. Okay? Okay. The new keyword is what we'll see on when we actually create an instance of a class. That's on the using the constructor side. Okay. If we see the new keyword on that side, we know we're using a constructor because the new keyword's always involved with constructors when we're using them. I'm talking about the definition of it. I see a constructor written up top, and then I see some methods written below. Outside of identifying the return type and saying, oh, well, this guy has no return type, he must be a constructor. Other than that, how do we know that this guy's a constructor and these guys are methods? Yeah, class name. Class name. Constructors will always, the name of a constructor will always be identical to the class name in Java. So if I have a class named player, the constructor, its name will be player, okay? And it will have no return type. That makes sense? Constructors would never be static. Can't have static constructors, okay? But you can have static methods. Static methods means they don't belong to an instance of a class. Instead, they belong to the class itself. So if we had a static method inside of the player class, we would say player dot the name of the method. Make sense? As opposed to p dot the name of the method, where p is an instance of player. So that gets back to this question right here. Understand static versus non-static. Okay. Super, super important thing. Right? So in the big scheme of things, even though it seems like we're talking about a zillion different things, we're talking about a pretty small core competency of Java. But that core competency of Java is the most important thing to programming. All that other fluff is stuff that you can work with just by being able to read documentation. Okay? And stuff that you'll get better at by solving problems. The more problems you solve with a program, the better you'll get at problem solving. Most of you are going to suck at problem solving right now. Okay? And it's not because you're stupid. Okay? It's because you're inexperienced. You haven't solved enough problems yet to run into all the errors and all the little idiosyncrasies and things like that you've, I guarantee when you were 1, okay, you tried to put the little circle block inside the square. Okay? Over and over and over again until you finally decided that's not going to fit. All right. In fact, my mom tells me I did that for a while. In fact, at some point, I think I really forced it through. It's like, well, it will fit. Okay. But I mean, that's human nature. We have to take it as a sport. If you play basketball, you play soccer, you try 50 different things until you finally figure out the way that works for you. Okay, or the right technique for shooting a free throw, or the right technique for kicking a soccer ball a long distance, right? I've always found it fascinating how the goalies in these professional soccer teams can kick the ball like 3/4 of the way down the field. I was in school. I was always like the king of kickball. I could kick that. The rubber airfill, the rubberized ball, that I could kick that really far. But a soccer ball, I couldn't kick anywhere. Like 50 feet or 40 feet or something like that. I was on a soccer team one time, and I remember the coach on the other side when I was getting ready to kick, he yelled to his team, weak foot or something like that. Yeah, it was demoralizing. I'm remembering that, 30 years later. It's stuck with me. Okay, that's going to come with time. That's going to come with problem solving, over and over and over again. Okay, you're supposed to still kind of suck at that. You should suck less at that today than you did at the beginning of the semester. So, hopefully all of you can kind of do a self-assessment and say, I'm better at it than then. Okay, but I'm not as good as I want to be. All right. Let's see here. Okay. Oh, and also make sure if I ask this question, variables always resolve to their. Make sure you use enough ends in definition. Understand the members of a class. Classes are comprised of fields, constructors, and methods. Those are the dudes we'll find on the playing field of all objects. All right. So fields are the variables associated with an object. Constructors are the tools that don't have return types because they always return memory addresses that always match the name of the class that we use for actually constructing an instance of this object through the new keyword. Okay, when we actually use it. That's what constructors are for. They actually construct the object. Methods give us abilities within those objects. Here's the public, private, protected stuff. Understand those things. I probably would not ask this question directly. Give me the little blurb, public, private, protected. What does each one mean? I would probably ask you to kind of show me that you understand the concept through an example or something like that. Mutators, accessors, /getters, setters. I probably wouldn't ask the question related to mutators, accessors. That's more of like a history lesson thing. Everybody today calls them getters and setters. Nobody calls them mutators and accessors. That's more for, I don't know, the episode of Jeopardy that's on history of computer science. So you can get that one right on that show. I should see if I can, that would be a funny thing. I should contact Alex Trebek and see if I can get him to give me an audio bite of him saying, kind of write the question the right way, mutators versus accessors, and we'll have a daily double, a video daily double in class at some point. Okay, so this is kind of our inheritance model that we talked about. So we have at the top level, all objects inherit from object. Okay, this is how Java implements object-oriented programming. When you take the 470 class with me, which is the hardest class in our program. So be prepared for great fun. It's also my favorite class, so I just go crazy in there. You think this is unstable, just... That class is just impossible. Students love it. But we actually write a programming language in there. And part of that is we write how object-oriented programming would be implemented. And it requires a creator, okay, as we make the God connection, right? So we have the top level object that must exist. That's the cornerstone of it. And then we all of our other objects are made in its image. Okay? That's Christian worldview all day long. Point. Okay, it's triple point. All right, so this guy inherently exists in Java. Okay, that guy's already there. And if we don't extend something, magically we're extending that guy. Okay, we're extending object. But we have our manager and player down here. I think our last homework assignment was to create managers, right? And then have our list of managers first and then players second. So we would have had to do that, play that game of emptying out that vertical linear layout each time we came back there and then refilling it, doing the managers first, then doing the players. So you maybe would have had to use some instance of practice to kind of pull that guy off. All right, so when we create a manager, manager's extended human. So a manager is a human, which is an object. Okay, so humans get everything that objects have. Managers get everything that humans have, including all the stuff that objects have. All right, that's the inheritance model. So understand that guy. When we deal with array lists, understand, does anybody remember what that is called? There's a term it's an object-oriented term. It's a specific term Java uses that says what it means to create an array list with this syntax following it, the angle brackets, the type it holds. Anybody remember what that's called? Probably wouldn't ask it on the exam. Those are called generics. Okay, in Java, it's called generics. That name changes in different languages. So that's more of a Java-specific thing. But the concept traverses the languages. So just like the this keyword. Many languages use this keyword. Some use self. Visual Basic uses me. But they all mean the same thing. They're all how an object refers to itself from within itself. Abstract. So when do we use the abstract? Where would we use the abstract keyword? Let's start with that. Where in your program, what location in your program would you expect to see the abstract keyword? As far as what I've taught, it actually can be used in another place too. Go ahead. Okay. So you would see it when you're making a class, you'd see it to the left of the word class, right? And what is that? What does the abstract keyword mean? Go ahead. All right, so it locks the class down. It says you're not allowed to make instances of this guy, which means that it's strongly encouraging you to inherit from this class. Okay, or it's saying you just wasted your time. One of the two. Okay, this guy's eye candy. It's just there to make your program look like it has more source code files or something like that. So it encourages us to inherit from that guy. Now, based on that concept, when might you put abstract in front of a method? I haven't taught this yet. Let's just extrapolate. So the abstract keyword can actually be used in front of methods as well. When might you want to put the abstract keyword in front of a method? Go ahead.
I don't know if this is a good answer, but maybe if you're
Probably not.
if you're documenting your own code and you've created a method that you haven't used yet, maybe use the abstract keyword.
Okay. Well, if the abstract keyword before a class says you're not allowed to create instances of this class, what do you suspect that the abstract keyword in front of a method means? You're not allowed to call it. Okay. So through the inheritance model, you, let's say, get that method, but you're not allowed to call it. So why would you do it? Goes back to the slide right after polymorphism. We talked about polymorphism as it relates to another concept. What was the other concept that's similar to polymorphism but slightly different? Method overloading. So when you put abstract in front of a method, you're strongly encouraging the class that inherits it to overload that method with its own version that's appropriate for that class. Does that make sense? Okay, so you might have an abstract class for human, and that abstract class for human might have an abstract method called display. So you're encouraging all things that are humans to have a method that displays the object. All right. Now, managers might display themselves in terms of their first name, their last name, their, I don't remember all the stuff we have, years of experience, age, whatever we had. Okay. Managers might talk about that stuff when they're introducing themselves, when they're displaying themselves. A player would display themselves in terms of first name, last name, jersey number, skill, that kind of stuff. So both of those guys are capable of displaying themselves. Okay? But, and they're both, we force them to be capable of displaying themselves because we threw an abstract method instead of in front of human. But by making it abstract, we're saying, look, managers, you have to be able to display yourselves. Players, you have to be able to display yourselves. So far as I've said, you have to write this method. You have to implement your own version of this abstract method that does what it means to display you. Okay, what does it mean to display a manager? Rewrite that abstract method with the logic inside of it for displaying things related to displaying a manager. On the player side, rewrite that abstract method with the overload, that abstract method with the logic that is appropriate for displaying the details of a player. That makes sense? Probably won't ask you a question related to that, just kind of extending that knowledge of where you can use abstract because they haven't seen that in practice, but that's kind of where abstract could also be used. That's actually related to another concept that we'll talk about next semester called interfaces. Okay, interfaces are our way of forcing objects that implement that interface. Interfaces are similar to inheritance. Okay, so we can extend a method, that's inheritance, or we can implement an interface. And when we implement an interface, we are agreeing to implement all the stuff that the interface says we have to have. Okay? So that's kind of a foreshadowing thing. All right, so be able to create array lists of that know how to hold certain objects. So be able to understand the syntax and the concept of generics. Probably I wouldn't ask you to come up with a name, generics. Abstract keyword important. Instance of. What is instance of? Tell me everything you know about instance of. I suspect you used it relatively heavily in your previous assignment. Unless you didn't do the previous assignment. You may have used it sparingly in that case. What is instance of? What kind of thing is that used for? If we have instance of, if we see that, we're likely creating what kind of animal? Who? Okay. Yeah, we're checking to see if something is an instance of a class, and so if we say, is this guy an instance of this class? What is that whole line there? What would we characterize that? I'll give you multiple choice. It's creating an instance of an object, cat, dog, or Boolean expression. It's a Boolean expression, right? Boolean expression. So we're saying if this instance is an instance of this class, if that's a true statement, what are Boolean expressions? Boolean expression, that's any expression that boils down to a single value of true or false. All right, I assume everybody took my advice and you say that 100 times before you fall asleep each night. Your whole life doesn't revolve around programming? Yet? Just wait. Can you imagine? I sometimes sit around and I program for fun while watching Netflix. It's just like going out and shooting hoops, or that's going to be your life. Like, what are you doing? I'm coding. All right. So the instance of operator is an operator that allows us to check, ask the question, is an instance that we have sitting here actually an instance of this other dude over here, this class? Okay, so it's a way for us to determine whether something is an instance of a class. Now, when will we use instance of? Give me an example of when we might use instance of, and I'll kind of put this slide up for no particular reason. There actually is a particular reason that I put this slide up. So give me an example of when using instance of would be appropriate. Go ahead. Okay. So we wanted to store things that were humans. And we had two different types of humans. We had managers and we had players. Both of those guys were humans. Okay? So with that in mind, what did we do? We said, I'm going to create an array list capable of holding humans, which now allows me to throw anything that is a human into that array list. I can throw managers in there. I can throw players in there. Can I throw humans in there? Why not? Because who? Well, yeah, so we already know we're going to throw players and managers in there, but why did I make this guy red? Why can't we throw humans in there? Go ahead. Not private. What's the what's kind of the equivalent of private? Oh no, move away from those guys. We've been talking about it for the last several minutes. Abstract. Okay, so human, we made that guy abstract so we would never actually have instance of human, right? Tactically, we could throw humans in there if we could ever create an instance of human, but we can't because we made it abstract, specifically in this case, right? If we hadn't made it abstract, which then would allow us to create instances of generic humans, then we could throw humans in there as well. And then we would turn this guy to blue from red in my color scheme, right? Okay, so we said we have an array list of humans, even though we're never actually going to store a generic human in here. We're going to store things that are humans, things that have an is-a relationship with humans. That whole is-a relationship, not a made-up word. That's an object-oriented made-up word. Okay, it's part of that actual object-oriented ecosystem that some guy that was hopped up on something way long ago when object-oriented languages were created came up with, I guess. So a manager is a human, a player is a human. So that means that both of those guys would be fair game for throwing into an array list capable of holding things that are humans. Okay? So now when would instance of be used? When we start taking stuff out of this array list, they're going to come out wearing a generic human mask. Okay, and we need to determine what's under the mask. Is there a manager under the mask, or is it a player under the mask? And that's where we use the instance of operator to ask that question. Are you a manager or are you a player? That make sense? So that would be an example of when we might use those guys. Okay. So that's all our new stuff. Let's see about our old stuff, what things I feel is important. If I were to grab a question off this slide, one of the questions I tend to like asking is involved with the char primitive type. I might ask the question of why is the char primitive type unsigned? Okay, and I would expect you to give me an answer somewhere along the lines of, well, the char primitive type actually maps to the Unicode character set, which is numbered 0 to 65,535. Probably wouldn't ask you to memorize that number, but bonus points if you do, I guess. But so we don't need to hold negative numbers. So a signed value knows how to hold negative and positive numbers. An unsigned value doesn't know how to hold that sign. So it only holds positive values, which happens to suit our needs for the char primitive type, because that guy ultimately maps to a Unicode value. Make sense? Not promising it'll be on there, but if I were to ask a question on here, it would be something like that. I very likely would not ask you to recreate this slide, although maybe you should hope I do, since you're going to be using your notes. 5 minutes, just go down the list. But I would, the types of questions I like are more competence questions, not regurgitation questions, which is why using your notes doesn't really benefit you that much. Plus, as we've seen, sometimes I ask questions I never even covered. It's a habit. What are you going to do? Okay. Yeah, so that's the Unicode crap. Conversion stuff, we already have that on our list. Out of desperation, I could ask you to tell me what a Boolean expression is, but I would just expect you to show me you understand those guys. And I know we're out of time, so let me just zip through here real quick. I probably won't ask anything. Well, I'm going to say bitwise is fair game for the conversion question, but I probably would not ask it. That's going to be more of a mood-related thing. If I decide I'm in the bitwise mood, I could ask it, but I care more about the conversion stuff, I think. Obviously, be able to use the logical operators. I would not ask anything about the shift operator. Be able to create variables, be able to do conditionals, loops. Probably wouldn't ask you types of programming languages. Variable scope is important. I don't know if I'll ask you a direct question with that, but it's entirely possible in one of the programming questions that you'd have to show me you understand how scope works. Understand what contiguous memory is as it relates to arrays. So memory in a row and why that's important for speed. New keyword, pointers, and I think we're pretty much up where we were. Be able to write methods, obviously. Variable passing thing, pass by value versus pass by address. Again, I probably wouldn't ask it directly, but if I told you to create a method that took in an array but didn't have a return type, understand that was passed in by address. Okay, I think that covers everything. Questions, comments, concerns, bribes? All right, I guess I'll see most of you next semester in 300. Remember, even if you're an IT major, 300 can be used as an elective. I would highly, highly, highly encourage it. Because programming is an important aspect of IT. Do not view it as IT means not programming. Okay?